Okay, so I'm back with another video, and in this video I'm going to teach you how to integrate with partial fractions. Now, what is partial fractions essentially? You see this fraction, I can factorize this using the midterm factorization, and this would be equal to 4 divided by x squared plus 7x minus 2x minus 14. I can write this as this. It's the same thing because 5x is equal to 7x minus 2x, so it's the same thing. So this is how I factorize this. And I get two factors for this single polynomial, which is x plus 7 multiplied by x minus 2. Actually, right. X plus 7 multiplied by x minus 2. Now you might think that substituting one of these expressions or this entire expression might result in 4, but that isn't the case here. I can assure you about that. And so there is a new technique on how to do this. I take this entire expression, 4 divided by x plus 7 multiplied by x minus 2, and then I split it into two expressions, and each expression has one of these factors as the denominator. So the first expression has x plus 7 as the denominator, and the second expression has x minus 2 as the denominator. Now the numerator for a general partial fractions question is always 1 degree smaller than the denominator. So I can say it's just a constant value, and so I take it as a and b. Now I will convert this into one term. So that would be equal to, I will multiply x minus 2 in the numerator and the denominator in the first expression, and this, and I will multiply x plus 7 in the numerator and the denominator of the second expression. So I have the same denominators, which is essentially the same as these denominators. So what I have in the end is 4 divided by x plus 7 multiplied by x minus 2 is equal to a into x minus 2 plus b into x plus 7 divided by x plus 7 multiplied by x minus 2. Now what I do is that first I will simplify this as expressions of x. So the denominators are the same, so I just remove the denominators, and what I'm left with is x into a plus b minus 2a plus 7b. Now x has x has no coefficient on the left hand side, while it has a plus b on the right hand side. So I can say that a plus b is equal to 0. I compare the coefficients of the left and right hand side, and I conclude what equation I get from that. This is basic algebra, and similarly for this constant value I have 4 to put in. Actually, let me just put in a before. Minus 2a plus 7b. If I just multiply 2 into the first equation, I get this, and if I add these to its equations, I just cancel out the a part, and I have 9b is equal to 4. 9b is equal to 4. If I just replace the value of b, which is 4 by 9, in any one of these, I get a is equal to minus 4 by 9. A is equal to minus 4 by 9. And b is equal to 4 by 9. So my integral is 4 by 9, the negative of 4 by 9 divided by x plus 7 plus 4 by 9 divided by x minus 2. So I just split it up into different integrals, and the 4 by 9 being a constant stays out of the integral, so I have 1 plus 7 dx plus 4 by 9 multiplied by 1 by x minus 2 dx. Now this is just simple integration. This is a recognizable form which we have done before, which is simply the log base e or ln of the modulus of the denominator. The ln of the modulus of the denominator plus 4 by 9 multiplied by x minus 2, which is the modulus of the denominator, and obviously plus c. This is the final answer that we get on integrating this. So let's just have a quick run through of what I did. This method is known as partial fractions. First I factorize the denominator, and then I split the denominator into different expressions with each factor as one of the denominators. The numerator is always 1 degree less than the denominator, and then I just took unknown constants on both the expressions. So I have a and b over here, and then after forming a whole equation, I compared the values. X has no coefficient on the left hand side, so a plus b was 0, and minus 2a plus 7b was 4. That's how I got this value. And after replacing a and b over here, I just switched this out and put in this right here. This is a recognizable form of integration, which is the ln of the modulus of the denominator, and so we have our answer. So that's it for this video. Thanks for watching. I'll be doing improper fractions in the next video.